I'm going to introduce the topic of quadrilaterals. Specifically, I'm going to define what a quadrilateral is. I'm also going to define what people mean when they talk about the area of a quadrilateral. I'm also going to talk about what people mean when they say that two quadrilaterals are congruent. And finally, I'm going to investigate the sums of the interior angles of quadrilaterals. All right, so let's get started by defining what a quadrilateral is. A quadrilateral is a polygon with 4 sides. So remember that polygons are figures on planes with sides that are straight line segments. So apparently a quadrilateral is a figure in a plane with 4 sides, 4 straight line segment sides. All right, so I can give you some examples. There is an example of a quadrilateral. There's another one. There's another one. We can even have goofier looking quadrilaterals. The only requirement is that it has to be a polygon with 4 sides. Okay? Now, what do people mean when they talk about the area of a quadrilateral? So, area, loosely speaking, has to do with how much space a figure takes up. All right? To give a measure of the amount of space that a quadrilateral takes up, we need to define a standard measure of area. One standard you could use is a square centimeter, which is roughly about the area of this blue square. All right. So to calculate the area of a quadrilateral, you need to count how many squares you can fit in that quadrilateral to exactly cover it. Okay? Now, the first quadrilateral that I drew apparently has an area of roughly 4 square centimeters. Okay? Now, if it wasn't exactly 4 square centimeters, we would give a fraction or a decimal. Maybe the area is 4.3 square centimeters, for example. So it's perfectly fine to talk about portions of that blue square when you're calculating an area or communicating an area. Okay? And so for the other quadrilaterals, again, we would have to figure out how many blue squares it takes to cover the space taken up by the quadrilateral. Okay? So every area calculation is going to involve the same idea. And then the last one, of course, it would be more difficult. You'd have pieces of quadrilaterals to handle that shape. All right. Now let's switch gears and talk about what people mean when they say that two quadrilaterals are congruent. Okay, so the following is true for any two figures that are congruent, not just quadrilaterals. Two quadrilaterals are congruent if they have the same shape and size. All right, so if you thought about that, you would come to the conclusion that for two quadrilaterals to be congruent, in other words, to have the same shape and size, they have to have the same corresponding, they have to have congruent corresponding sides and angles. Let me type that out. Two quadrilaterals are congruent if they have congruent corresponding sides and angles. All right, so for example, let's say we had this quadrilateral, and let's say we had another one that we thought might be congruent to it. All right, and let's label the vertices of the quadrilaterals. Maybe we'll call them the points A, B, C, and D. And for the other quadrilateral, U, V, W, and X. Okay, so what does it mean for this example to say that the corresponding sides have to be congruent? Okay, well that means that length AD has to be equal to length UX. Length AB has to be equal to length UV. Length CD has to be equal to length WX. And length CB has to be equal to length WV. All right. Furthermore, we have to have the measure of angle A equal to the measure of angle U, the measure of angle B equal to the measure of angle V, the measure of angle C has to equal the measure of angle W, and finally the measure of angle D has to be equal to the measure of angle X. So hopefully now everybody understands what is meant when someone says that two quadrilaterals are congruent. Now, let me close by investigating the sums of the interior angles of quadrilaterals. You may know that the sums of the interior angles of all triangles, the sums of the measures of the interior angles of a triangle add up to 180 always. All right? Now, it'll turn out that for quadrilaterals, the sums of the measures of the interior angles always add up to 360 degrees. Okay, let me repeat that. The sums of the measures of the interior angles of every single quadrilateral, the sums will always be 360 degrees. Okay? Now, why is that always the case? I have a slick way to convince you that that has to be true. Okay? Take any quadrilateral. How about the following? Okay? Now, do you agree that I can chop that quadrilateral into two triangles? Okay? Now, we know that every triangle, we know that the sums of the interior angles of every triangle, the sums are 180. Okay? So, two triangles, the sum of the angles for two triangles is going to be double that. So, 2 times 180, so 360. Okay? Now, the reason we're going to get 360 for every quadrilateral is because you can divide every quadrilateral into two triangles. Okay? There's a goofy looking quadrilateral, but watch this. I can divide it that way, and once again I have two triangles. Okay? So the sums, once again, the sums of the measures of the interior angles of all quadrilaterals add up to 180.